Okay, Ji, fine. There is a difficult question on Kirchhoff's law. Here it is. Okay, the two cells of EMF E1 and E2 and negligible internal resistance are connected into the network in A as shown. We can clearly see a complex network in which there are two cells, this one and this one. A number of resistors are connected. Number of different direction currents are shown in the circuit. And the circuit is labeled as A, B, C, X, Y, Z, and blah blah. Anyways, they say the current in the network are indicated in 7.2. Use Kirchhoff's laws. They have not said what law, but they said use Kirchhoff's laws to state the relation between currents I1, I2, and I3. Okay, if you talk about Kirchhoff's laws, there are two Kirchhoff's laws. Kirchhoff law number one, law number two. Law number one is related to current that we already know. Here it is, Kirchhoff's first law. Okay, like I equals I1 plus I2 plus I3. Total current reaching a junction equals total current leaving it. And Kirchhoff's second law, total EMF in a closed loop or closed circuit is equal to the total potential difference in that loop or in that circuit. Okay. Anyway, so for the first part, because we are supposed to talk about the currents, so the first law must be used here. And in order to use the first law, it is very simple to first of all select one of the junctions, okay, in the circuit. I find two junctions in the circuit, B and Y, and we can select any one of them. Which one would you like to select? Tell me.
B.
B. Okay, we selected B. Now, see which current or currents are reaching a junction. I mean, reaching B. If we talk about I1, is I1 reaching B or leaving B?
Reaching B.
Reaching B. I2 reaching B or leaving B?
Reaching.
Reaching. So I can say that sum of the current, like total current reaching junction B is I1 plus I2, and there is no other current reaching B, okay, equals to the sum of the current or total current leaving it. How many current or currents are leaving junction B? I can see only
One.
one, I think, right? I3. Okay, I3. So actually the equation is I3 equals I1 plus I2. I can write this equation in any ways, like it can be written like I1 plus I2 equals I3 as well, okay? Because mathematically they are equal to each other. I hope you understand that, right?
Right.
Okay, now if you think we are selecting Y, we will again be making the same equation. How many currents are reaching Y? Uh, Only one, I3. Can you see I3 is coming and reaching Y? Uh, I I1 is actually leaving Y.
Right.
Can see this is I1, 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 right? And in the same way, I2 is also leaving Y. Okay, so some of the currents reaching Y is I3, and some of the currents leaving Y is I1 plus I2. It is the same equation, right?
Right.
Anyways, so yes, first part is done. Let's talk about the second part. And the second part says between E2, R, I2, and I3 in the loop BCXYB. They have given us a hint. They told us to select a loop BCXYB. BCXYB. They mean to say you have to select this closed loop only. Forget this part. Cut this part from your circuit. Okay, and consider only BCXYB, and then write the relationship between E2, R, I2, I3, and all. Okay. It means they must be talking about closed loop law, and that closed loop law is definitely Kirchhoff's second law, right? Anyway, so what I'm going to do, I'm going to consider this loop, this one, and I'm going to work on that. See, first of all, on this loop, tell me how many sources of EMF are there only on this loop?
One.
One only, and that is E2, right?
Right.
Okay, so the law says sum of the EMFs in the closed loop, like E2 only, equals to the sum of the potential difference in that loop. Okay, potential difference is definitely across the components like R and R. So, potential difference equals IR. This is R, and how much current is passing through this R?
I3.
I3. Okay, there is another thing that needs to be noticed here. I3 is directed in this way, means this way, means this way, right? Means this way. Tell me whether I3 is supporting this E2 or opposing this E2. Like, is it according to E2 or opposite in direction to E2?
It's along the conventional current.
Okay, it's same direction. Means, E2, like, EMF number 2 will be giving the current that has same direction as I3. Okay, and is this the same direction as I2 as well?
Yes.
Yes, it means I2 and I3, both the currents will be taken as the positive currents according to my EMF. Anyways, what I'm going to do, I am going to take the voltage of this one, that is I2R, and I2 is positive, and the voltage of this current is, I mean, this resistor as well, I3R, that is also positive. I told you the reason behind this positive sign, because positive sign is taken as both the currents are are arranged, or you can say have the same direction as E2. So that's the reason why I can say that I2R plus I3R. So my equation must be E2 equals I2R plus I3R. Okay. And accordingly, what I can do, I can take R common, I2 plus I3. So the equation, final equation I should write here, R common, I2 plus I3. I hope you understand it, right?
Right.
Okay. The last thing is left, and the last part they say between E1, E2, or I1, I2 in the loop A, B, C, X, Y, Z, A. A, B, C, X, Y, Z, A. I'm getting back to the diagram. A, B, C, X, Y, Z, A. Okay, so yeah, here you go. A, B, C, X, Y, Z, A. They mean to say you have to select this loop and only forget this part. Understand?
Yes.
Okay, fine. So it means I'm supposed to again use the Kirchhoff's second law that states that sum of all the EMFs in a closed loop equals sum of all the potential difference, right? Okay.
Right.
So sum of all the EMFs I'm going to write on left hand side of my equation, and this is simple. Sum of all the EMFs. There are two sources of EMF now, E1 and E2, right?
Right.
Okay. First, tell me whether they are connected in a right way or in a wrong way. What I mean, shall I write as a resultant, shall I write E1 plus E2 or E1 minus E2?
E1 minus E2. Opposite.
Okay. Okay. E1 minus E2 because this positive terminal is connected to the positive terminal of the other cell. Or you can say that the current of this one is directed in this way, and the current of this one is directed in an opposite way, right? So E1
Right.
minus E2 or E2 minus E1, right? So let's say we are taking E1 minus E2. E1 minus E2. Okay, fine. And on only on this path, we have to see the load resistors. There are three load resistors, 1, 2, and 3. And through this one, there is current I1. Even through this one, there is current I1, right?
Right.
Okay. Tell me, is I1 opposing the EMF E1 or supporting the EMF E1?
I1 is supporting E1.
Supporting E1. You mean to say direction of current due to E1 is same as I1. So yes, it means I1 I'm taking positive. Okay. And if we talk about I2, can you see I2 is going this way? Okay.
Yes.
I yes, I2 is not supporting E1, it is supporting E2. And E2 I have taken negative, right?
Right.
So in this question, in this part, I should take I2 as negative current. Anyways, what I'm doing now, the voltage of this one is I1R, right? I1R.
Right.
I've already taken this voltage. Now the voltage of this one is also I1R plus I1R. And I1 is taken as positive current. And the last one is left, this one. This one has a voltage of I2R but with minus sign. Understand?
Yes.
Okay. I1R and I1R makes it 2I1R and minus I2R. This could be written as your final equation. Okay, or even you can take R common as well, right? So E1 minus E2 equals 2I1R, okay, minus I2R. I hope you understand it, right?
Yes.
Now the question is raised, if one of these students say, no, I'm going to write E2 minus E1, okay, then this equation will go reverse, will be equal to I2R minus 2I1R, okay? And mathematically, both the equations are same, okay? Understand?
Okay. Yes.
Fine. So these type of questions are asked for Kirchhoff's law, and I am going to show you a few more questions, just like this one, an MCQ that have been asked in the recent year, the latest paper, October November 2022, paper 1-3. See, three batteries and three identical resistors are connected in a circuit PQR as shown in the given figure. Okay, the batteries have negligible internal resistance. What is the potential difference between point P and Q? They're asking you, if we connect, let's say, a voltmeter here, so what will be the reading of the voltmeter? Anyways, what we are supposed to do, we are supposed to apply Kirchhoff's second law in this question as well, and we are supposed to find out the voltage across the points PQ. Anyways, the first thing that I don't know here that I'd like to find here is the potential difference across each resistor. Can you see these are three identical resistors, right?
Right.
Okay, tell me the total EMF of this whole circuit. This is 9.6, this is 8.4, this is 6.3. Tell me which ones are taken positive and which ones are taken negative. For example, I'm taking 9.6 positive. Will I take 8.4 positive or negative accordingly?
Negative and then
Good,
6.3 positive.
negative, and this one is
Positive.
positive. Okay, now tell me the resultant of all the EMF in this closed loop, like 9.6
7.
minus 8.4
7.5.
plus 6.3. What?
7.5.
7.5. So you know the total EMF is 7.5 volt. Now tell me this total EMF is divided equally among how many resistors?
3.
Three resistors. If we divide 7.5 by 3, we get 2.5 volt.
Yes.
Okay. That means what I got to know that, the potential difference of each resistor is 2.5 volt each, right? And 2.5 volt. Understand?
Yes.
Okay. Now, because we are working across point PQ, so across point PQ, there are two things: one battery of 9.6 volt, and the other is a component of 2.5 volt, right? Tell me which one of them is an energy provider and which one of them is an energy consumer. Yes, 9.6 volt provides energy or consumes energy?
Provides energy.
Provides energy. And 2.45 volt
Consumed.
consumes energy. Okay. So, we are provided with 9.6 volt. Okay. And how much is consumed? 2.5 volt is consumed. Okay. So what will be the resultant voltage across point PQ? 9.6 minus
7.1.
2.5. What is the answer?
C. 7.1.
You mean 7.1 volt. 7.1 volt is the answer. Got it?
Yes.
So it's a long question, but we applied simply the Kirchhoff's laws and found the answer. Even Kirchhoff's second law is used here to find the answer. What we found, first of all, we found the resultant EMF across the whole, in the closed loop. And then we found, the voltage or potential difference across each resistor. Then we found the potential difference across the 2 points PQ. Understand? Yes, understand?
Yes.
Okay, fine, perfect. But there could be negative potential, negative voltage as well. For example, if they ask you a question here, tell me the potential across QR. This one will be taken negative. Okay, this one will be taken positive. So the voltage here is 6.3 minus 2.5. What answer comes?
Uh,
I think for
3.8.
3.8 volt with positive sign. But if they ask you here, negative 8.4 volt already, and this is also negative. So I think you should give the answer as 10 and 10.9 with minus sign. A negative volt means the something that is always a consumer, but usually they don't ask these kind of questions like negative volt. But I hope you understand uh, the whole logic, right?
Yes.
Okay, fine, perfect. I'm going to solve only one more question, and inshallah you will be able to understand all the rest of the parts, and you can solve the rest of the parts of your own from Kirchhoff's laws. See, this question is from winter 2017, question paper 1-3. They say three identical cells each have electromotive force E and negligible internal resistance. The cells are connected to three identical resistors. Each of the resistors are as shown. Okay. What is the potential difference between point PQ? Exactly the same kind of question. Okay, they repeated, but in a different way. Now they ask you the potential difference across PQ here. And we know three sources of EMF are there. Okay, in this closed loop. I take this one positive. You will tell me whether this is positive or negative.
Positive.
Positive, perfect. And this one will be taken positive or negative, this one?
Negative.
Negative. So the total EMF in this closed loop is E plus E minus E. One E is cancelled. The total EMF comes E only. Agree?
Agree.
Okay, fine, perfect. So we understand in this whole closed loop, the total EMF is E only, right?
Right.
Now this total EMF is divided again equally because there are three equal resistors, and this is called potential divider circuit, as though all these three resistors are connected in series combination. So don't you think the voltage across this R1 is E by 3, this R1 is also E by 3, and E by 3 for this as well? Agree?
Agree.
Good, fine, perfect. Now we are supposed to work across point PQ. One is energy provider and the other is energy consumer. Okay. law of conservation of energy. So this is 1 plus 1 and this is minus 1 upon 3. Either you use your calculator and calculate the resultant fraction like 1 minus 1 upon 3, or you can take an LCM even, and this
2e
comes
over 3.
3e minus e. Yes, what answer comes? 2e upon
2e
3.
over 3.
Yeah, so the answer comes C here as well. Got it?
Yes.
Okay, so I hope you understand how we will be using the Kirchhoff's laws and will be solving the questions, right?
Yes.